Hi, my name is Taren, and I'm a rising freshman at Los Gatos High School. My project is the object tracking robot, and so let me share my screen. Okay. So this is my demo video. This is my project demonstration for my object tracking robot. To start the robot, I press the on button. Once it has booted up, I am ready to start the tracking process. All I do is click this button. Once the button is clicked, it'll take the picture, which is signaled by the yellow light. And what it's doing is it's getting the color from this object so it can track it. And now it's ready to track. So it should follow the object as it moves around. And it'll keep a distance between itself and the object. And what I can do is I could then press the button again if I wanted to track a different object. Okay, so this is a brief overview of my robot's components. Over here in the back, I just have a normal power bank, and then I have a mini breadboard that has the lights to indicate the Raspberry Pi's status. I have a button that's hidden by these wires, and when I press it, it'll just restart the script to track a new object. I have my Raspberry Pi, of course. And then in the front, I have a flashlight. This project is kind of light sensitive. So if you're to do this at night, you need a light source. That's why I have the flashlight. I have a Pi camera to take the video, of course. And then an ultrasonic sensor. Now what an ultrasonic sensor does is it sends a pulse through this little eye-looking thing, and the pulse will bounce off the object, and it'll get retrieved by this eye-looking thing. And then by measuring the time that it takes for it to receive that pulse, you can measure the distance in centimeters or any measurement. And then in the back here, hidden, is my motor driver. So one of the components of my project was to figure out how to put the Pi camera and ultrasonic sensor onto these two screw holes. And in order to do this, I had to CAD model a mount. So for my first challenge, I had to write a script that could track any object. Now, I didn't really know how to do this because I haven't worked with Raspberry Pi ever. I've only been doing Arduino projects. So I familiarized myself with OpenCV and how to take video. And so what I ended up doing was searching online for what's the best way to track an object. People were saying that color is one of the easier ones to use. So I ended up taking a picture of the object that I want to track, and then extracting the color from that picture and using that to track that object. So this is a picture that my Pi camera took of the target object. And I ran my script. I thought it'd work, but it didn't end up working. So I was kind of stumped. I didn't know what to do. After doing a little bit more online digging, people said to convert your RGB image to an HSV image, which stands for hue, saturation, and value. Now, what that would do is it would create a lot easier of a recognizable object. Here, let me just show you. This is an RGB image, and this is an HSV image. There's a clear distinction between the object and the background. You can also see that there's hardly any shadows on the object compared to this. So what my actual script does is it takes a picture of that target object. It runs an algorithm that I created to sort through the darkest RGB colors and the lightest RGB colors. In order to mask an object, you need the lightest and darkest colors, so you can create a range, and it'll track any of those colors within that range, any of those shades within that range. So just for future reference, in my case, a mask is just defining the object's outline or the color of the object's outline. So as you can see here, this is during the tracking process. This is the color mask, and the white is what color is being detected, and the black is what is not being detected. So what my program does, it'll put a line through the middle of the detected or white part, and that way, when this white object moves to the left or the right, the line will also follow. So then I can say if the line's on the left side of the screen, turn to the left to face that line. Now you may see that there's a little bit of masking or color detection in the bottom left, and that's just this part. And that can happen. It's not perfect, but it's just grabbing the biggest color mask. So my second challenge was figuring out how to turn the robot to face the object without overcompensating. So it sounds easy to just move the object to the left if the object's on the left, which I thought was easy. But what happened was the motors were so powerful that it just turned way too far past the object. And that would cause it to then think that the object's now on the right. So it then turn to the right, and it just do the same exact thing over and over again. So I decided that I should just lessen the speed of the motors. That ended up not working because there is a lot of weight on this robot, and it just can't handle that much weight with such little speed. So then Fred came up with a great idea of turning the robot in ticks. So every time it would just tick to the left if the object's on the left, process that frame, tick to the left, process that frame. So this way it'll actually know where the object is at all times and how it'll calculate how much more it needs to tick. So this was a great way of tracking that object. So when I came to Bluestamp, I was looking for a challenge, and I definitely got a challenge. I also wanted to broaden my horizons. I've only been working on Arduino projects. So to try something new and work with the Raspberry Pi, that was totally new. I didn't even know how to code with Python or anything. So working with Bluestamp has really got me into this new microcontroller. And of course, I need to know a lot of different, I need to know how to use a bunch of different microcontrollers, because there's not going to be one specific job for any microcontroller. So reflecting, I have strengthened my coding and robotics abilities by far. And what I want to do with this project in the future is I want to figure out, so you know how I mentioned that there's a lot of different ways to detect objects and track them. One of them is using object classification, kind of like what Luke did with classifying whether it's a dog or not, or a cat. I want it to actually look to what that object is and track it solely off of what it is. So thank you for listening. Any questions?